The first law of thermodynamics is that energy is conserved. And we've already done this, right? We've done conservation of energy problems, right? Another way of saying it is that it's zero sum. So if I put a hot piece of metal in cold water, right? The Q of this guy is positive, right? Or the Q of the water is positive, and the Q of the metal is negative, right? And that adds to zero, okay? So energy is zero sum. Whatever amount of energy there is in the universe, the net changes are going to add to zero. That's another way to say it, right? You could say input equals output. These are the formulas we use, right? We've solved these things. And you will see people propose that there are violations of conservation of energy. An example of this is perpetual motion machines. Now, not only are they perpetual motion, but somehow they'll get more energy out of them than you put in, right? And my sister was an engineer at Portland State University for a few years back in the 90s. And people would come in with these machines, and of course they'd set them up in an isolated situation, and eventually they'd run out of energy, right? Because as far as we know, there's no long-term violation of the first law of thermodynamics. You can't get something for nothing. Some years ago, there was a faculty member at this school actually approached me because there was some swindler, in my opinion, that had this electrical box, and you put it in your put it in your house, and it will generate more electricity than it takes off the grid. Well, no, it can't. I'm sorry, you can't do that. You're not going to find that. Okay. When I was 11 years old, I read about transformers. Right. To me, they were these magical things. Right. You had iron core. This is a piece of iron, and you have 10 windings here, and you have 100 windings here, right? So you take a 9-volt battery, and by the way, it only works with alternating current, right? I wasn't clear about how I would do this, but if you took a 9-volt battery and just switched it on and off, you could generate 90 volts. Here, if this was 100 windings, right? So I was inspired by this. I was like, well, I could make something that would turn 9 volts into 110, right? So therefore, I could power the entire city of Cedar Rapids with a 9-volt battery. And I told this to my mom breathlessly. I was like, wow, you old people really just don't get it. All you need is a transformer, a 9-volt battery, right? And my mom said, bless her heart, didn't like physics, had to take it because her father was like literally was a physicist, a PhD. But my mom said, look, honey, I don't know what's wrong with what you're saying. I can't point it out, but you're violating something. You can't get something for nothing. She remembered the first law of thermodynamics, right? So there you go, right? So first law is you can't get something for nothing. For nothing. There's no free lunch in the energy world, okay? And if somebody's telling you that there is a way to do that, they're wrong. All right? I don't think there's anything else to say about the first law.